Hello people, just a quick look at quadrilaterals, four-sided planed figures. Firstly, the interior angles of a quad add up to 360. So special quadrilaterals we're looking at. Firstly, the trapezium, which is a quadrilateral with only one pair opposite sides parallel, as you see is indicated on the diagram. You can also refer to the notes in PDF form. Then an isosceles trapezium is a special trapezium where the non-parallel sides are now also equal in length. So we still have our one pair of opposite sides parallel, but then those that aren't are also equal. Then for the parallelogram, it's a special quadrilateral with both pairs opposite sides parallel. So that's its definition. So then from there, you can see all these other properties that I've marked out on here with their special colors. I just want to point out diagonals bisect one another. So as you can see, the diagonal over here is not the same length as the diagonal over here. Because it's skew, it squishes these two angles together, and so the diagonal becomes shorter and these two get further apart, so that diagonal becomes longer. And so when it's bisected, this little part that's been halved is the same as that little part, but because this line is a separate or a different measurement, this little line's measurement is the same as that. So I can't give them all the same marking. So I made a squiggle over here to indicate that they're the same length, and three lines to indicate that they're the same length. And then for a rectangle, it's a parallelogram, a special parallelogram with one right angle. So it's got all, you'll see, so it's a special parallelogram. It's named that because it's got all the properties that the parallelogram has and some extra ones of its own because it's special. So the diagonals bisect one another, and therefore, since they are equal in length, and the reason for them being equal in length is because it's upright and not like this one where that one squishes, those two angles squishes together, and so this has become short, this becomes shorter and that becomes longer, the diagonals each time. So because it's upright with the 90-degree angles, these lengths are the same for the diagonals, and so you'll see I've given them all the same markings. So you can have a look at all the rest of the properties over there. Then for the rhombus and the square. So for the rhombus, it's a parallelogram with two adjacent sides equal in length. So it's like a parallelogram, skew, etc. All the properties of a parallelogram, but it's just got all the sides equal. So you'll see I've given them all one line on it only. But then the diagonals bisect one another at 90 degrees. So I've given a 90 degrees over there, and they're bisected, but they're not equal in length once again because it is skew. So I've given that two little lines as a marking, and these two halves, three little lines for a marking. And then something else, the diagonals bisect the angles. So this angle is the same size as that angle, and so the little bisected parts will be the same size, and this angle is the same size as that angle, and so the little parts will be the same size. The square is a rectangle with two adjacent sides equal in length, or could be described as a square, as a rhombus with one right angle. Okay, so as you can see, all the sides are equal. That's why it could be called a rhombus, or as a rectangle because of the right angle, but then just the adjacent sides are equal in length. So two pairs opposite sides are parallel, two pairs opposite sides equal, just like the parallelogram, but once again what's special is the diagonals bisect each other at a right angle, and that's for this and this true because of the sides all being the same length. That's what causes for it to be cutting at right angles. All angles are 90 degrees, just like the rectangle, and then the diagonals are equal in length, once again because it's an upright figure because of the right angles. And now, once again, the diagonals bisect the angles, but this time it forms 45-degree angles exactly. Okay. Kites are quad with two pairs adjacent sides equal in length. So that's the definition, what makes it special, the adjacent sides. But we can distinctly see which two adjacent sides are equal. We're not going to say this adjacent side is equal to that one. It doesn't even look equal. So that's that. And then diagonals intersect at 90 degrees. So there are the diagonals going from vertex to vertex, and it cuts. That's what intersect means. Cuts at 90 degrees. And then one diagonal bisects the other, and so you'll see that if you look at this diagonal, it forms two congruent triangles. Okay, you'll see it looks exactly the same. So we cannot think that this this line is bisected. It doesn't look at that little part, doesn't look the length of that little part, but surely that looks the same. Okay, so that's the diagonal that is bisected by the long diagonal. Then one diagonal bisects the angles, so it's also the long diagonal that bisects the angles because the equal angles from the two different triangles. Okay, so that's what happens. And then one pair opposite angles is equal in size, and once again from our two triangles being formed by the longer diagonal. And then an arrowhead is also a kite. Then you can also just have a look at the work below.